If you're cutting squares or rectangles that are all quantities that are all the same, then we can save a lot of material by using an array nest. So array nest is this plate fill function here. So what we'll do is we'll create a shape and we'll fill a plate completely with them. So they might be floor plates or something. So we go to flexi shape, onto our generic shape. We'll create a new shape. We'll make a floor plate. We'll make it 200 wide by 150 tall. The 5mm lead in. So as our basic rectangle, we'll stick some circles in this. So we'll stick a circle in 20 diameter. We'll stick it 20 across and 20 up. Then we'll do another cutout circle, 20 diameter again. We'll stick it 180 across and 20 up. Another circle, 20 diameter. We'll stick it 20 across and 130 up. And another circle, we'll do this one 20 diameter again. We'll do it 180 across and 130 up. So there's basic floor plate, rectangular plate. We could stick a hole in there if we wanted. So we'll save that, and we'll save that as 200 by 100 floor plate. Okay, so there's our shape. So we don't want to do anything with that now on here. What we want to do is go to scan and nest and choose plate fill. So first select file, then specify plate size. So import flexi, it could be an NC1 file. We've just made a flexi shape, so we'll click on import flexi. There's our shape we want. So we scroll up till we get to 200 by 100 floor. Next. And what it's done is we've told it our plate is 800 by 1200. We can edit these, so we can make that 1000. See how many we get in there. It's got a border around the outside. Once we've changed that, we press renest, and it'll calculate again. So we can see that we're actually getting 28 plates in there, 4 by 7. We could rotate the part, renest. We're saying we get 30 in that way, so that's a better way to cut it. So once we're happy that we've got our maximum utilization in there, if we press next, it'll now process that, and we go into the cut screen. This is already set up beforehand, and press start. Select the origin first, press start, and what it'll do is it'll cut these 4 holes first, and then it'll go around and cut the outside of that shape. So that'll take a while, so we might just speed through some of this. So as it cuts around this shape, it will then, once it's done the last one, which I think is that one, it will then cut the outside. So what we'll do is we'll stop it there, and we'll speed through these next holes. One, because there's a few of them. And through to these last ones. Okay, so what it does now is cut the holes. So now we'll jump to that point. It will then cut the outside, so it'll come across the bottom here. And up the side and along in a staircase. So we call this a staircase cut, and it will continue on this shape until it's cut the entire lot. So it'll cut the next set of holes with this set here, and then it'll do another staircase up around the outside there and back down again. So each line in the middle is a common line cut. So this line follows this 2 parts here, this is these 2 parts. So basically it's reducing the cut time considerably, because these are all double cuts, so one cut equals 2 components, and it's reduced the scrap allowance to 0 in the middle here, because there's no scrap at all. So you get maximum plate utilization and maximum cut speed out of this particular shape. So that's